Please, just a second. Okay. So we're wrapping up with our afternoon activities. We're going to have another keynote presenting right now. We're going to start now with Dr. Dallas Card, an assistant professor in the School of Information at U of M. His research focuses on making machine learning more reliable and responsible, and on using machine learning and natural language processing to learn about society from text. Dr. Dallas Card will talk today about the important topic of evaluation and values in machine learning and natural language processing. Please welcome Dr. Dallas Card.
Thank you. Thank you. So I'm really excited to be here today. I was honored to receive this invitation to speak. And I decided to give sort of a somewhat different talk than I normally do.
You have to click into the PowerPoint.
There we go. Great. And specifically, I thought I'd try to draw together a few different strands of research, which I think of connecting broadly to this question of values, which is obviously not the same as ethics, but bears an important sort of connection to it. So the sort of motivating questions for this talk are things like, where do values come from? What values are salient in the AI community? And how do these values translate into practice? Now, values is obviously kind of an ambiguous or vague term, but generally speaking, I won't try to give a terribly precise definition of it. Rather, we're thinking about things like beliefs, motivations, principles, concerns, priorities, etc. Really anything that influences how we choose to act in the world. So the sort of things that drive our actions and our choices, these are important to think about in terms of the way we're building AI and the outcomes those will have. Now, it's easy to find examples of sort of individual choices that draw connections directly to certain specific values. So, for example, some people choose to not work on certain technologies or problems because of concern about societal impact. Joseph Redmond, who was a computer vision researcher, decided to walk away from the field because of concerns about military applications or privacy concerns around surveillance. At a higher level, some people might choose to not take funding from various organizations, depending on what sorts of beliefs you have about the kinds of values these organizations hold. And at a higher level, we see sort of community-wide action on various questions. So maybe the best example of this is in 2018, the inventor of CRISPR received an email with the subject line, "Babies Born." And it turned out a researcher in China had used this gene or DNA modification technology to modify the DNA of human embryos. And once the babies were born, only then did they notify the inventor of this technology. Now, there hadn't necessarily been a comprehensive set of rules in advance of this, but there was a very swift reaction among the entire community to say this was entirely unacceptable and that there should essentially be a kind of moratorium on this research, at least for the time being. So if we zoom in for today, title obviously of the forum today is Building Ethical and Trustworthy AI. We can set aside for the moment the question of what AI is, because this is a very broad term that includes a lot of different things. And so we'd probably choose to focus in on these terms ethical and trustworthy as the sort of most value-laden terms in this title. Again, there's a lot of room for disagreement on exactly what ethical and trustworthy mean, but this is a strong statement that we're trying to imbue certain values in this technology. At the same time, we shouldn't lose track of this term building. The way this is written is clearly adopting a stance that we are or should be engaged in building these sorts of technologies. And we could contrast this, for example, with a question like, should we be building ethical and trustworthy AI? Now, I'm not going to take a clear stance on this at the moment, but just to sort of set the stage in terms of thinking about how values enter this discourse. So there's three parts to the talk today. The first is to give one example of sort of the way in which values emerge or propagated through a field. The second is looking at specific values found in the fields of ML and NLP. And the third looks at ways in which these values translate into practices, specifically around data selection, evaluation, and deployment. So on the propagation of values, obviously we are all individually influenced by a number of different things, including our families and friends, backgrounds, etc. But there's also a lot of ways in which the community we are a part of shapes the way we think about what is good or desirable. Now, machine learning and natural language processing are two key parts of AI, and they sit arguably on kind of a spectrum between science and engineering. Obviously, these science and engineering have some similarities to each other, but they're also sort of different at a high level as well. Where we might think of the key values of science as being something like discovery and explanation, whereas engineering is, on some level, more focused on sort of solving practical problems. Now, machine learning and NLP both have questions they're trying to answer, in some cases purely theoretically, but on the whole, especially these days, there's a strong focus on actually building things to be put into the world in a sort of practical manner. And so we should expect the values associated with these fields to be sort of somewhere in the spectrum here, possibly leaning more towards engineering. Now, on the sort of scientific value side, we saw the reaction of the CRISPR scenario as being a sort of strong expression of community norms. If we look towards engineering, I want to start with a brief digression into what I call the culture of engineering. Now, this is something I wrote about quite a long time ago, so it's not as up to date as the rest. But a lot of people have written about the way a culture emerges in engineering through education and practice. And I think we can say that there's sort of three key ideas which tend to be a core part of conceptions of what engineering is. A core one in almost all definitions is this notion of solving problems. So there's a focus on finding problems in the real world and finding practical solutions to those, often through mathematical or other means. Second, there's a strong emphasis on responsibility. So engineers are taught to feel as though they have a sort of responsibility for society, both in a legal and an ethical way, to try and help people and do the right thing. And there's also a kind of sort of modernist bent to all this, where everything's aligned with a trust in reason and technology and progress. And again, that's not to say this is unconventional or wrong in any sense, just that this is sort of a community norm that emerges in various ways. If we look, for example, to the definition from the Canadian Council of Professional Engineers, we note that they note that there's many different ways to define an engineer, including things like knowledge, demographics, and institutions, the sort of regulations and codes that are in place, so statutes, codes of ethics, et cetera, and specifically this obligation and commitment to the public interest. So this is like one body's vision of what an engineer could or should be. But there's also a lot of ways where these things emerge in a more sort of subtle manner or a more cultural way. So for example, in Canada, there is a ceremony called the ritual calling of an engineer. This is a ceremony held upon graduation from an engineering program, where people are basically given this sort of ritual that is also known as the iron ring ceremony, where engineers obtain their iron ring, which is a sort of symbol of the responsibility of the engineer, with the notion that when this clinks on the side of a drafting board or a beer glass perhaps, we're reminded that the things engineers build may impact people's lives in a very direct way. And so this is sort of a ceremonial way of reminding graduates that they have this sort of connection to society and this sense of responsibility with enduring symbols like the ring that's given to all the graduates. Interestingly, there's also a lot of more sort of symbolic aspects to this. So for example, there's often the use of some sort of poetry in these ceremonies. In some cases, this poem called The Sons of Martha by Rudyard Kipling, which was written in 1923 and inspired by a story from the Christian Bible. And so in this poem, engineers are likened to the so-called Sons of Martha, who are sort of portrayed as being the hardworking and capable ones, but those who have a sort of burden to care for the rest of the society. That's being the sons of Mary, who are able to live sort of carefree lives, not worrying about these details. So this is a very sort of niche context. This is an old text. This is used within a Canadian context, not necessarily American. But it's a nice example of the kinds of ways in which the organizing bodies for communities try to inculcate people into certain ways of being. This is partly through coursework, partly through legal regulations, but also through various cultural aspects that shape the way people think about themselves and their role in society. If we think about computer science, there's many places we might look for equivalents. So there's the professional society of the Association for Computing Machinery. There's obviously ethics courses people take, various popular media depictions of what a computer scientist is, slogans, etc. This is a whole nexus of ideas about what computer science is or should be that on some level shapes the way people think about their role as computer scientists, the way they could or should do things in the world. Now, of course, there's still a huge range of diversity of how people practice their profession. Within the realm of sort of design, we can think of everything from a kind of ultra-modernist take, like the city of Brasilia, designed top-down to live in the jungle and transform the landscape, to something like appropriate technology, where the focus is on a small scale, working with local conditions, trying to enable and not disrupt as much. So even though people come from similar backgrounds in terms of an educational context, people find their way to practicing different roles in society. And there's a huge room, amount of room for disagreement. But on some level, there are these sort of both top-down and bottom-up processes shaping the way people conceive of their role in society. Now, if we look to the fields of ML and NLP specifically, we can ask, what sort of values do people hold? And I'll point to 3 different ways to try and get at this. One is simply to look at what people say they value. Another is to ask them what they think. And the third is to infer values from their behavior. So in terms of looking, we can again look to the ACM, the professional society. And on their website, they have 4 stated core values, along with a mission and a vision. And these, in this case, are technical excellence, education and technical advancement, ethical computing and technology for positive impact, and diversity, equity, and inclusion. So these don't necessarily tell us a whole lot, but they do put the focus on technology, on excellence, on positive impact in the world, on a sort of inclusive environment for education and technical advancement. It sort of helps to give a sense of what, from a top-down perspective, the field should think is important or valuable. Now, that's all of computer science, which is obviously much broader than just AI. In more narrow context, we can look, for example, to academic publishing policies, which are constantly in flux. So for the Association for Computational Linguistics, which is sort of one of my core areas, in 2021, people were first encouraged to include an ethics statement on their papers to describe the broader impact of anything they're doing. The next year, there was a responsible NLP checklist that was added as a requirement. And this covers things like the hardware used to run the experiments, whether there are human subjects involved, whether data was being created and distributed, and so forth. And just most recently this past year, we're now required to also include a limitations section to discuss possible limitations of the paper. And all of these are given as sort of extra space beyond the 8 pages that are given for the research in a way that sort of emphasizes these are things the community wants people to value in writing papers and doing research. A similar experiment was tried for NERPs in machine learning, where in 2020, authors were required to submit a broader impact statement as part of their papers. But in this case, it was actually dropped a year later, in part because these are organized at kind of a local level. And so research on how these went found that although some people did invest things in them and come up with very useful insights, others tended to mostly emphasize the positive impacts of their work rather than negative. And there's a lot of skepticism these were even being taken seriously, with some people noting they seemed more like a bureaucratic constraint than actually a meaningful way to describe what was happening. So this gets at some of the tensions for values in the field, where from a top-down perspective, people want to emphasize things like broader impacts and ethics, but there may be resistance among the community that has skepticism as to the value of these things. A different way to get at this is just to ask people what they think is valuable. Within NLP, there's work on a community meta survey, which tried to get at the concerns and questions people had. And this was targeted at those who are actively publishing in the ACL venues, and they managed to get about a 5% response rate. So this is not huge by any means, and it's certainly a biased sample in some ways, but they do get at a fair broad coverage and get some diversity of opinions being surfaced. And interestingly, they asked both about people's personal opinions on these questions, as well as their expectations of others in the field. So you get both the sort of aggregate of opinions given and how people think the field as a whole believes. So for example, there was a question about the influence of private firms. And a majority, 77%, felt that private firms have too much influence on the field. But interestingly, the expectation was lower. So the aggregate of people's impressions of the community was that only about 61% would feel this way. So this shows both a gap between individual perceptions and the perceptions of others, but nevertheless gives us a sense that this is a concern people have. People see the influence private firms are having, and they think maybe it is too much. perhaps unexpected, or perhaps unsurprisingly, the question of the greatest consensus was that on net, the vast majority believed NLP is having a positive impact on the world. So 89% either agreed or strongly agreed that there's a net impact of a positive impact of NLP, which is interesting because there's a lot of concerns in the field about possible negative impacts. Nevertheless, people feel the positive outweighs the negative. By contrast, a majority nevertheless thought that the majority of research being published in NLP is of dubious scientific value. A lower agreement rate, but still 67%. So this points to a kind of strange disagreement where people are questioning and skeptical of what people are doing at a scientific level, and yet they think there's a positive impact of the field as a whole. And yet a lot of this impact's happening through corporate influence, which people are also concerned about being too excessive. So again, we're finding there's a lot of tension in these fields, a lot of room for disagreement, but overall, there are consensus values that emerge. The last point I'll point to in terms of inferring or understanding values is my own work on the values of machine learning. And here we use the fact that scientific papers are kind of a valuable commodity, where we know there's a lot of credit that comes from having a paper in a venue like NeurIPS. And moreover, people have limited space to emphasize why their work should be published. So we chose to focus on the 100 most cited papers from a few years of NeurIPS and ICML, two top machine learning conferences. And we manually annotated data for a set of values using a code book we developed as we went along, also looking at justification, funding, and any ethical concerns that were raised. And so what we found as kind of a high-level takeaway was that there's really 6 values which emerged as kind of a dominant consensus set of values that were emphasized by the vast majority of papers. And perhaps unsurprisingly, these were largely sort of quantitative scientific type values. So things like performance or accuracy, generalization, efficiency, as well as this notion of novelty. So authors are very keen to point out that their papers were doing something new that hadn't been done before. And really what this tells us is not so much that authors themselves necessarily value these things, but that they believe reviewers value them and want to see them in the work. So by choosing to emphasize that our paper gets great performance and is a novel method and we're building on past work, they're sending a message in scarce space to reviewers to say, we think this is what you care about, we're going to tell you that we're delivering on that. On the other hand, only about 4% really tried to justify a connection to any kind of societal impact. So there's a fair bit of gesturing towards the fact that machine learning could or maybe is having a positive impact on society through curing cancer or helping people discover information, but very few papers try to make the claim they themselves were doing that. Rather, we might say there's a potential for unsupervised learning to help with these tasks, but let us focus on the narrow quantitative aspect being discussed. And even more concerningly, only 2% of these papers discussed anything about any potential negative consequences. And this is despite the fact that some of these papers dealt with things like deepfakes or misinformation or other sort of serious topics and concerns. So overall, this paints a picture of the field of machine learning, at least in people's perceptions, being primarily focused on sort of novel quantitative work without worrying too much about whether there's an actual impact on society. We should note, however, this is something that changes over time. So for most of these values, these are quite hard to identify in any kind of automated way, but there's a few exceptions, one of which is this notion of the state-of-the-art performance, which is basically any claim that the work being presented is doing better than anything that's come before. And what we found is this is really an emerging value, where back in 2005, very few papers made this claim. This is now an analysis of all papers published at these two conferences using automated methods. Whereas now, today, about half the papers being published claim they get a state-of-the-art result in some capacity. So this is clearly seen as something that reviewers want to see and is considered as meaningful or important for scientific work in these fields. So just to summarize how we think about inferring values for a field, again, we can look at what people say, we can ask them their opinions, and we can infer from behavior. And this tells us both that there is room for disagreement on many of these questions, and yet a lot of sort of consensus values, at least in terms of perceptions of what people think we value. Now, some of you are probably wondering, why does this all matter? And the reason I think it's important is because values guide the way we practice research and research development. And so I want to point through 3 different avenues in which values translate into practice. The first of these is data collection or data selection. We think a lot about data, of course, anyone working in data science. There's the terrifying aspect that anything we do only creates more data. But generally speaking, we don't just create our own data, we go and gather it from the world. And a key values question that arises is sort of who has the rights to data, or by what rights can we claim data? Many of you may know the book by Shoshana Zuboff from 2019 called The Age of Surveillance Capitalism. It's a very wide-ranging book, but she makes a very strong case in it that for developing Google Maps and Google Street View, Google practiced a fairly aggressive practice of essentially just going out and gathering what they could. When they encountered resistance or regulation, scaling back or putting things on pause, and then returning later to gathering more data and seeing what they could get away with. So practicing kind of an ask forgiveness, not permission type of approach. And nowadays we see something very similar happening with these large language models, for example. So as far back as BERT from 2018, 2019, we know there were works under copyright that were included in the training data. Someone noted at the time that it was sort of shocking that Google or Microsoft would even allow copyrighted work on their servers, because for so long, internal lawyers have been concerned about any potential cost involved in this. But there's been a gradual erosion or change such that now there seems to be very little concern for this topic altogether, with, of course, models like GPT being trained on a huge amount of text scraped from the web, such that there's now lawsuits ongoing where, for example, there's a class action lawsuit against Microsoft for how they've used code from GitHub, which sort of ignored the terms of service of these licenses. So Microsoft, of course, claims fair use, that they're having a transformative impact of this data and therefore are sort of able to use it without compensation, whereas others allege there's a clear terms of service and they shouldn't be violating that. Again, there's not a clear answer. This is in some ways common practice for many people in the field, but it clearly goes against certain values that are long held in terms of ownership, right to one's creations, and so forth. These are the kinds of things that are emerged from both regulation but also individual choices of researchers and practitioners in the field. In the case of large language models, not only are there questions of like what data should we use, but even the question of what data was used is in many cases large open territory. So especially for things like ChatGBT, this hasn't really been shared in a very transparent way. So there's work, for example, from the Washington Post trying to document what exactly goes into this training data. And you see, for example, that Wikipedia is one small part of this and an important source for a lot of these models, but only one tiny fraction of a much larger data set. We also, for example, patents and any number of other sources involved. My own work on this has looked at the data set for training GPT-3, and specifically this notion of high quality text. So like many models of the sort, OpenAI turned to Common Crawl as a source of diverse text from the internet. This is basically a huge terascale or terabyte scale scrape of the World Wide Web, where they just sort of grab everything they can. And this naturally produces a data set with all kinds of pornography and hate speech and boilerplate and all kinds of things that we don't necessarily want in training the model. So to filter this, OpenAI developed a simple, essentially logistic regression model to try to distinguish what they call high quality text from low quality text. Now they don't explicitly define quality, they simply say things like Wikipedia and news articles are examples of high quality text. So they will take those as positive examples, train a model to find data that looks more like that. And again, it's not to say we shouldn't make models that try to create language that sounds like Wikipedia or news articles. It's just to say that to call this high quality text is a kind of language ideology that suggests some sort of writing or speech are better than others. And of course, this then leads us to ask, whose language counts as high quality according to this filter? Using a sort of method I won't go into the details of, we looked at a data set comprised of articles from high school newspapers, which gives us a very broad and representative sample from across the United States. And what we find is that those articles from high school newspapers in areas that are wealthier, more educated, or more urban are more likely to be rated as higher quality according to this filter. Now, because of the way US politics works, this also means that in general, those schools from heavily democratic areas will be rated as higher quality than more Republican areas. Again, this is not something we think OpenAI set out to do. This is not intentional bias they're building in. This rather emerges from this sort of implicit notion of how they defined this notion of quality and how they built a model to select text for their model. We also look at a number of other dimensions, such as factuality. So using a data set rated in terms of high factuality and low factuality news based on independent assessments, we find there's basically no difference between these in terms of the quality filter used. So this filtering step is is making decisions largely based on style. This is independent of the factuality or reliability of these articles. And again, this is something that filters into the model and downstream applications. So again, we're not saying there's any way to sort of avoid this problem. Any data set we build will be incomplete and biased in various ways. The point is that in choosing what to use, we're expressing various values we hold, either implicitly or explicitly. And at a minimum, we should be transparent about the choices we're making and thinking through how this might affect downstream users. There's also other great work I'll point you to, such as a paper by Jesse Dodge, which looks at a different way of filtering the same data, in that case using a simple word list of sort of bad language, which they found had the impact of potentially marginalizing discussions of sexuality or race and things like that more generally. Okay, second way in which we see values translated into practice is evaluation. And this in some ways is, I think, something that we think of as sometimes secondary or after the fact, but actually shapes a lot of the way we even practice anything in the field. And in particular, we have to think about why we're doing evaluation. Rarely do we even get at the question of, is this asking big societal questions, or is it just doing something cool? So why do we evaluate at all? There's many reasons, but I'll point to 4 in the slide. The most basic is probably to estimate performance. This is the first thing anyone learns in a machine learning class, where to do proper evaluation, you need a clean train, validation, and test split. The reason being that if you use data for any purpose other than evaluation, you may be unintentionally biasing the result. So by having a test set you hold out for final evaluation of your final model, you get an unbiased estimate of performance on data from that domain, assuming you have proper IID data with test data drawn from the same distribution as the training data under the standard assumptions. So this is useful maybe to say my model has 89% accuracy or something like that. An extension of that is to say you want to demonstrate improvement. So you're not just assessing the level of a model, but you're saying my model is better than yours. And more generally, this leads to sort of measuring progress as a meta-value, where we want to see progress towards a task over time as newer models or newer data sets lead to higher and higher numbers. This is not how things were always done. As we saw before, the idea of a state-of-the-art result is only something that's fairly new relative to the past couple of decades. This sort of benchmark approach really emerged in the 1980s, largely based on sort of shared tasks around speech recognition, and has since become a fairly common way of doing things in the field, where someone will create a data set and people will compete to get the best possible number on that, claiming improvement over past work. At the same time, there's other things we might think about as why we do evaluation. One is to try and understand things like failure modes, or perhaps assess fairness or safety or things along these lines. There's a lot of work that does pursue this, but this is still not the norm in terms of when you see an evaluation of a paper. Mostly it's serving to say my model's better, not to say here's how my model might fail. And for more ideas on this, there's a nice survey based on talking to people who do natural language generation, discussing their sort of challenges and thinking about how should they do evaluation, what are they even trying to achieve. Slides mangled a little bit, but it's still legible. So one of the works I've done on this looks at this sort of question of fairness in evaluation. And what we found is that within NLP, in many cases, people seem primarily keen to demonstrate their work has improved upon past work. And what might happen is that someone takes a baseline as is, but then devotes a lot of effort to improving their own model, doing things like hyperparameter tuning, and then showing that they get a better result than the baseline. This obviously creates a kind of unfairness if we're giving more effort or more consideration to the new method without being sort of fair to the earlier one. So in this work, we show that you can take this into consideration by designing a scheme where you map out the space of hyperparameters and give an equal amount of time or computation to all methods, letting them sample randomly from that to develop a sort of sense of the expected performance of a model if you only had a limited budget for hyperparameter tuning. And the net result of this is that it often turns out to be there is no such thing as the best model overall. As long as we're talking about a model design, not a specific instantiation, the best model may be a function of the budget. So depending how many resources we'll devote to fine-tuning the model or to tuning the hyperparameters, a simpler model may be better when resources are more limited. Another paper on this topic looks at the problem of power analysis. And again, looking at research in NLP, we found that a lot of comparisons tended to be underpowered, which is to say people are not using enough samples to support any kind of meaningful statistical comparison on their analysis. And this was especially common for human evaluations, which is concerning because human evaluations are almost the only way to truly evaluate a lot of things in the generation space. Where we don't have good metrics for things like how good is the language produced by my model, people naturally turn to people to get the rated on dimensions like fluency or relevance or things like this. And so it's quite common to say, take 100 examples of text, get people to rate these, and then present the results in a table. This definitely has information in it, but is not usually an evaluation designed to support a conclusion like we are doing better on evaluation for fluency than these other approaches. So we might ask, how much of this evaluation could be considered performative? Is it really there to make a strong claim about a model, or is it mostly there to sort of impress upon reviewers that we've done something reasonable? The other thing we can think about is, again, this rise of benchmarks. As mentioned, there's been a huge sort of focus of the community upon benchmark tasks such as glue and superglue, which typically gather together a wide range of tasks like question answering or sentiment analysis and say which model does the best of these across the board. And arguably this has done a lot to drive progress. So by creating these shared data sets, it becomes much easier to compare performance and really pushes people to innovate to try to exceed performance from past methods. But there's also a lot of concerns that have been raised by this approach. One, for example, is that this leads primarily to a focus on benchmark climbing and simply doing better than the previous methods by all means necessary, rather than really thinking about why we're doing what we're doing. These may also inflate expectations relevant to actual real-world performance, given that people are optimizing for specific data sets and claiming to do something like question answering, even though it's a much more general task. They also perhaps focus excessively on one number. So here we see there's a single score that says this model is a higher score than that one. There's a lot that's buried under that, both the individual task performance, but also things like fairness or bias are often not evaluated in these approaches. So there's work by Dan Jaratsky, for example, suggesting we could try to include a sort of customizability on this, where you might build in additional concerns like fairness and incorporate that as part of the leaderboard. But ultimately, some of this stems from simply the sort of quantitative focus on outdoing each other on shared tasks. Indeed, from this NLP survey, the second highest consensus result was that 88% of people feel there's too much focus in the field on benchmarks. So people are concerned that all the community's attention has gone towards trying to outdo each other. Now, that being said, there's not obviously an easy way forward past this. It's easy to say we should focus more on error analysis, but at the end of the day, people probably want to see you're doing something either novel or at a high performance in order to consider it worthy of publication. This becomes an especially large problem when it comes to large language models, which is where a lot of the focus of the community is today. So partly this stems from the fact we're now reaching for much more ambitious capabilities than we once had. It's one thing to say we want to do sentiment analysis and can use a benchmark data set to evaluate performance. It's much more challenging to say we want to do machine translation or question answering or language generation, where there isn't necessarily a single gold standard for what the result should be, and it's almost as hard to evaluate these things as it is to do the task itself. In addition, especially with large language models, where they're being trained in these massive data sets from the web, concerns like data leakage are a major factor, where we'd like to have a clean evaluation, but it's hard to guarantee that the evaluation data hasn't in some way been used in training the model itself. There's also concerns about explainability, where maybe we don't care as much about them passing the test as we do about what it means to do that. And of course, things like brittleness, where we know performance often degrades as you go from a well-defined task to something more in the real world. Especially with GPT-4, there's been a lot of at least media focus on things like passing the bar exam or the SAT or the GRE or any of these standardized evaluations. And in many ways, these are relatively well done. So if you look at the bar exam comparison, for example, this is an extremely difficult test. People study for months for this thing. They spend 12 hours in a room answering multiple choice and essay questions. And the people running this evaluation did at least some due diligence to say, here's some simple tests we can use to try to confirm that the test questions are not in the training data. So on some level, this is an impressive performance that shows the model is capable of producing answers that seem correct according to the evaluators of the bar exam. The problem are, one, we don't actually know quite what's happening behind the scenes. So there's been lots of cases where people found a model seemed to do well on a task, but then it was later found there were sort of unintended limitations or exploitable attributes in the data set itself. So for Squad, for example, it turned out the way people wrote questions unintentionally biased the answers that were likely. So if you use the word not in the question, that suggested a negation was probably the answer. Similar things may be happening here with the way we write bar exam questions that may not be apparent to human test takers, but might be available to the model. The other huge factor is that we should ask what the actual purpose of these evaluations is. So on the one hand, it is clearly an impressive achievement to do this. We could not create a model that could pass the bar exam even a few years ago. So on that aspect, this is some sort of accomplishment. But if we think about why we have the bar exam in the first place, the reason it exists is it provides a way to assess the quality of a human in terms of their ability to memorize and reason using a body of knowledge about the law, which we use a kind of threshold to say this person is now qualified to practice law in the state. And so we have a strong inference to say if a person can pass this exam, they're probably a reasonable lawyer and therefore should be certified. It's not a reasonable inference to say because a model can pass the exam, it therefore has the same additional inferences you can make about a person. So especially when it comes to things like medical certification, there's very little reason to think that passing a standardized exam is comparable to doing well as a doctor or a lawyer or things like that. Last little section here to talk about in terms of how values appear is in the realm of deployment. This will be much briefer, and I'll just touch on a couple examples. Many of you will probably remember from 7 years ago now, Microsoft's Tay chatbot. This was released in March of 2016, and it was designed to be a Twitter chatbot that would interact with users and learn from those interactions. And it was almost immediately targeted by various users for manipulation. And within 16 hours, it had gone so far off the rails, it was shut down, not even surviving for a single 24-hour period, unfortunately. I believe it was actually at some point accidentally reintroduced onto the web again and briefly tweeted some more and then shut down again. So this is a fascinating case study. One, because I think a lot of people feel like they would have seen this coming if they'd seen the proposal in advance. I don't know exactly who is behind all of this. Presumably there's some internal testing. But I think they failed to anticipate the extent to which, when confronted with a demo or a claim, people are so eager to try and break these things or find limitations or exploit them that a lot of attention will go to focusing on manipulating or breaking the systems. So I think this is a very predictable result that Microsoft somehow failed to anticipate. It was also a fairly large sort of PR disaster. It didn't prevent work on this. It sort of just became more private. So this is related to the Xiaolai system, or Xiaolai, that's very popular in China, and is sort of part of a long line of research on chatbots, which continues today. But they probably would have preferred to have this thing online for at least a day or maybe much longer to sort of continue learning. So the fact that they failed to anticipate this really led to this sort of limitation. And so that's why I was especially surprised when less than 7 years later, just sort of a few months after the release of ChatGPT, Microsoft again decided to, with great fanfare, announce they were integrating GPT into the Bing search engine. Now, as before, this produced all kinds of unanticipated results, where people found all kinds of ways to break this, concerning interactions, lots of misinformation, wrong facts, all the rest of it, and again produced sort of massive media attention and concern. The difference, of course, is there was no retreat in this case. So Microsoft really doubled down and said, this is the way forward, and indeed seems to have led the way with Google scrambling to catch up, even though Google perhaps had things they could have deployed much earlier. So you could say in this case, because Bing was so unpopular compared to Google, any amount of attention is actually a good thing, even if as much of it is negative. But more generally, I think it speaks to a sort of perpetuation of the sense that the way to produce technology is to put it out into the world and see what happens. That sort of become the de facto way to develop software, where we can't catch all bugs in advance. So let's roll things out, incentivize people to report, patch things as necessary. This seems to be the model that's largely been adopted and is now part of the commercialization of AI for a lot of fields. Ironically, this is somewhat ironic, given that this is a partnership with OpenAI, who is one of the first to sort of think through and try to push on the model of release. Whereas far back as GPT-2 in 2019, OpenAI chose to not release the large version of the model or the data set was trained on or the training code, precisely because they claim they're concerned about potential for misuse of this model. This has now been accelerated to a massive degree with GPT-4, where there's a huge dearth of details of exactly what was done. And it feels closely tied in with commercialization and so forth. But this really had a pretty big impact on the field, where before this, the norm in machine learning was, if this is science, you should be as open and public as you possibly can. This was a nonprofit at the time, and so they were claiming they were doing it more for scientific reasons. And yet, by not releasing things, they really limited the way people could work with these models and try to replicate things. This continues to ricochet through society. So at the moment, there's a lot of concern in the NLP community about how do we work with ChatGBT as part of the scientific ecosystem. Because it is among the biggest and best models out there, it's hard to ignore it, especially if it seems to be doing better on a task than anything you develop. But because we don't even know what's happening behind the scenes, it's of questionable value for evaluation. I mean, this is very unlikely, but you don't know, and there's always some chance things are being sort of manipulated behind the scenes or being modified periodically in ways we don't anticipate, meaning that it limits what we're able to do, yet also possibly invalidates a lot of work. So lack of openness is possibly a problem. On the flip side, there's now evidence that Palantir, for example, is trying to develop systems for things like battlefield simulation using open source language models that have been deployed. So this, again, is sort of an unintended use case, perhaps, but is in line with the sort of using what's available for the purposes we want them to. And again, lots of room for disagreement on whether this is appropriate or inappropriate, good or bad, just that these are individual choices from people emerging from the values they hold. And sort of an exercise to leave you with, I think ChatGPT provides a perfect example to sort of read into a system what values do we see in this deployment, in this product, in this science. As mentioned, the report really makes it clear they're not going to be transparent with anything related to training details or data sets. They claim partly because of the sort of corporate secrets type concerns. But we can ask along a number of dimensions in terms of how they got rights to the data, the compensation provided to annotators, the strategy they've chosen to release, the way they've established guardrails in the system, and so forth. So again, only one system of many, but provides a nice sort of case study for thinking about the way values impacted the choices the company made. So to summarize the entire talk, again, there's sometimes still a perception that a lot of machine learning is sort of a neutral mathematical field, even still today. And yet we found that values are actually pervasive throughout ML and NLP. Lots of room for disagreement among people in the community, and yet a fair bit of cohesion at the level of academic publishing, at least, where things like quantitative evidence and novelty are still very highly valued. This matters because the way we value things translate into the way we do science and build products, including things like how we select the data to use, how we evaluate and for what purpose, and how we choose to deploy. And so there's a lot of open questions to leave people with in terms of what values do we want for our community, how do we preserve scientific values in the face of commercialization, and how do we influence the direction of technological development. Just to end on a positive note, I'll say I think there's any number of ways we can influence the people around us and our communities more broadly, including both personally what we choose to work on, how we choose to evaluate our work, what we choose to build, as well as things like professional norms and standards, which there will be a distance from, but still has some top-down influence on people. And of course, this includes things like government regulation, but also just broader conversations we might have with each other in person or online. So I will stop there and say thank you very much and look forward to talking more today.
Thank you so much, Dallas. Now we have time for a couple of questions. 5 minutes.
I'll
Hi, thank you for wonderful presentation. I think you put to words really eloquently some of my concerns, especially in the first half of your talk when you're talking about engineers and their perspectives on ethics. Having recently graduated, I'm actually really concerned that a lot of research is really engineers often like tinkering with problems and as if they're in a vacuum without really taking into account the fact that the systems that they're working on have societal value, interact with humans a lot of the times, and there's this sort of arms race to the top that you alluded to as well. Do you have any perspective on how we can convince engineers to care more about ethics? I feel like I'm very frustrated about this subject because I'm very passionate about how, what we do really interacts and impacts people. But I'm not seeing it really taken as seriously as it should.
I think it's an awesome question. I totally agree this is a major concern. Because especially if you look at sort of the core of the discipline, it's easy to feel like the overwhelming majority has a very singular mindset of how to do things and whatnot. The more I think about these things, the more I really think a kind of like massively multimodal approach is the right thing to do, where I really think different approaches work for different people, and there's no one silver bullet that'll work for everybody. The original context of where I'd looked into the culture of engineering was actually looking at the organization Engineers Without Borders in Canada, which is focused on engineering for the benefit of international development. And the fascinating thing is that they'd started as a very traditional engineering approach where they sort of said, let's build technology for the developing world. But very quickly they realized that was not actually something that was useful or needed and completely reoriented towards being mostly focused on education within Canada and getting people excited about the fact that they could have real world impact on the most important problems in the world. But that, really making it clear that like going overseas was like the culmination of a lot of hard work, not the entry point into things. So that's a huge success story in my mind, where they got a big chunk of the Canadian engineering population to get excited about these problems and take a different approach. But there's no way that that specific example will work for the entire field. And so I think finding many examples like this, where you can get people excited either through media or books or certain problems that have a positive impact, it's going to be a sort of wide, big camp no matter what. But I am hopeful that there's a lot of excitement, even with engineering, for much more societally aware approaches.
I have a question in terms of.
So start the moment.
Okay, I have a question in terms of like testing the ability of the models, the ChatGPT series of models. I mean, like we can always create large data set in like large test set, but like, do you know any like innovative methods of creating the data set so that we can better evaluate different dimensions of the model's capability?
Yeah, it's a really, really hard thing to do. I think people often underrate the challenges of evaluation, which has only grown larger over time. One of the debates happening now is how much we should focus on essentially adversarial challenge data sets as opposed to sort of data collected in the wild. So especially as certain models have gotten better at certain tasks approaching sort of human level performance, there's been a push to say, let's gather especially hard examples and see how models fail on those. And I think this is interesting to pursue as kind of an error analysis type method, but it doesn't necessarily tell us much about how things will actually work in deployment. And really, the ultimate problem is that for something like hate speech, we come up with a sort of notion of what this means, but really the concept is operationalized through the data set we collect and annotate. And so we're only really working on the sort of implicit task defined through that data, not the thing we think we're doing necessarily. So I think the real answer is that we can never properly fully evaluate a model prior to deploying in the real world, both because the context will be different in ways we can't anticipate, but also because even deploying the model may have an impact that changes how people interact with it and so forth. So I think the question in some sense is both like how we can do better assessment in advance to help make sure things don't go badly wrong, like with Tay, but also how can we ethically evaluate in the wild, where we know we're sort of involving users in ways that they may not agree to with a product that may not be totally ready. And so thinking about small scale studies or getting people to opt in, large scale experimentation with guardrails, these feel important. But for something like natural language generation, it's just such an open question, like what the goal even is, that evaluation is extremely hard.
Thank you. We have time for one more question.
Hi. Sorry. Hello. Yeah. So you did all those review for the different papers that had to do that societal influence analysis. And also, like a lot of researchers often work on somewhat narrow problem, like sentiment analysis or text generation. And I can imagine why it might be difficult for them to ask them to do like a broader society analysis on the impact of their research. So I was just wondering, what are some particularly thoughtful approach you've seen people take to doing that analysis rather than just doing something that's more hand-wavy, satisfying the bureaucracy as some people see it?
Yeah, I think this is a fair concern in part because, again, there's a lot of different types of research that happen both within ML and NLP. I think especially for machine learning, there's a decent number of papers that are truly just doing essentially pure math, where they're working at some theoretical bound statistics or probability. And so I think there's a lot of resistance from those people to say, this really has no direct connection to societal impacts, maybe we use downstream, but I can't really speculate about ethical considerations. I think at the same time, having these forums in place is useful to have conversations because we know without them, there are lots of cases where people will work on a very problematic area, like deepfakes or things like that, and really not even talk about the potential concerns. So, there's a lot of experiments in NLP to say, how can we get people to think about and flag for reviewers issues with limitations or ethical considerations? I don't think anyone's totally happy with the state of the art right now. So the responsible NLP checklist got a lot of people revealing more information in a way that seemed useful. But I think people now see it as more, again, as a bureaucratic constraint because it's not clear anyone's looking at these things and so forth. So I think having the conversation is useful to get people thinking about it. I think some of the flagging limitations is very useful for other actors. So media look at our paper now, the newspapers look at our papers and report those results. If they see, oh, there's a serious limitation, they will then be aware of that in a way they might not otherwise. But yeah, I mean, if you're interested in especially good or bad examples of this, I'll put my slides online, and there's references to those works I cited that look at the broader impact statements, and they have some nice examples there.
Thank you.
Thank you.
Another round of applause. We're now going to have our final round of lightning talks. We're going to have 3 lightning talks. The first one